This will about that. About 2 minutes to wait, and then I suppose we can start.
2 minutes, yeah?
Okay. Dear participants, let me introduce myself. I represent National University of Life and Environment and Sciences of Ukraine, NULES. My name is Dr. Vadim Shkarupila, and prior to start, I just ask you if it's possible to switch on your cameras to make a snapshot, if you have the ability to do so.
Yeah, please, everyone, if you can open your camera for them to do screenshot. Yeah, please. Yeah, please, everyone. Join using your camera.
Dear Dr. James, I suppose we can start. I just introduce you to our colleagues from Ukraine. Dr. Jamila Bedarahim Jamila Sadeh from Technical University of Malaysia, Malacca. I think all who are interested in this lecture are already connected. And dear Jamil, you are welcome.
Thank you, Vadim. Okay, I would like to welcome everyone in my lecture, international lecture. So good afternoon to our Malaysian students here already afternoon, and good morning to Ukrainian students here. I think it's 10 a.m. So I would like to welcome all students from the University Technical Malaysia, Malacca, and from National University of Life and Environmental Sciences of Ukraine. Welcome everyone. Today we will talk about CPU scheduling. What is CPU scheduling? It's the method by which three processes or data flows are given access to system resources. So there are too many kinds of CPU scheduling. Today we will focus only about round robin. What is round robin? Round robin, this is type of scheduling algorithm is used in multitasking operating system, or you can say time sharing operating system. For example, when you are working on your laptop or PC, then at the same time you are listening music and surfing the internet, and also at the same time you are downloading some files or documents. So many processes are running. It seems that all the processes are running parallelly, but it's not true. It's based on the time quantum. Every process, the operating system will allocate some unit of time to each process. Maybe 2 milliseconds. So maybe for these 2 milliseconds, the CPU will be allocated the process which is running Windows Media Player. and another 2 milliseconds for some process is running maybe that maintaining the system clock of your laptop. So something like this, okay? And there is switching between these processes. And this switching is so fast that it looks like that all the processes are running parallel, but that's not true as I mentioned before. So this is what the multitasking operating system, what you can say, time sharing operating system. So those type of operating system for scheduling the processes, we use this kind of scheduling algorithm, which is round robin. So round robin scheduling algorithm is similar to first come first serve because we have too many types like first come first serve, like shortest job first. We will talk today about round robin. So round robin is similar like first come first serve, but with some time quantum, and it's always preemptive scheduling algorithm. Okay, what does it mean time quantum? It's time slice. The quantum or time quantum is the time or period of time for which a process is allowed to run uninterrupted in a preemptive multitasking operating system in one go. I will now show you in the practice how to draw the Gantt chart. So let's take this example. During I explain that this example, you will understand what does it mean time quantum and what does it mean. Okay, here we have 5 processes. Okay, each process have post time. Post time it's like amount of work or execution time. Okay, so we have 5 processes. We need to draw Gantt chart and calculate the average waiting time, where quantum given is 5 milliseconds. Okay, so this example is without arrival time. Later on, I will show you how to handle example with arrival time. So far, we will start without arrival time. Since there is no arrival time, so we will follow the given sequence in the table. So we will start execute P1, process 1, then process 2, and so on. Because there's no arrival time. If we have arrival time, we will follow which process arrived first, so we will execute the first process. You need to open AutoDraw. Okay, so as I mentioned, we will follow the given sequence in the given table. So means we will execute the first process. Okay, what is the mechanism here? The mechanism here, we will, okay, the given quantum is 5 milliseconds. Means we will execute 5 milliseconds from first process P1, okay? We will execute only 5 milliseconds. So we will follow the given quantum. As I mentioned, quantum is allowed, the time is allowed to execute each period. So we will execute 5 milliseconds, then we go to next process. Also, we will execute 5 milliseconds, and then we go to next until we reach to P5. Okay. After that, we will make a round back to P1. That's why we call it round robin. Okay. Till we execute all the given burst time or amount of work in the table. So let's start. We execute P1 from 0 until 5. Okay. from 0 until 5, and we reduce that 5 units which we just executed. So the remainder will be 7. 12 minus 5 will be 7. Okay, done. Process 1 done. We go on to next process, P2. Also we execute here because the quantum is 5 milliseconds. We go on to next process, P2. We also execute only 5 units from the total. Only 5 units, P2 until 10. Okay, and we write down the remainder of each process. Here the remainder will be 3. Because we execute only 5. Next, P3. The given quantum 5, but here the total is 4. So we can execute only 4. From 10 until 14. So P3 has terminated its task. There is no any reminder. Next, P4. Even the total is 10 units, but they allowed us to execute only 5 units. So 14 plus 5, 19. The remainder will be 5. Then P5, 5 units till 24. Here no any remainder. So P5 also has terminated its task. Okay, now we make a round back to P1. P1, the total is 7. We can execute only 5. So the remainder will be 2. 24 plus 5, 29. P3, P2, only 3 units. $32. So P2 has terminated its task. P3 also, and we go on to P4. P4, 5 units. Till 37. P4 has terminated its task. We make one more round to P1. P1 until 37 until plus 2 units, 39. Okay, so this will be our Gantt chart. Here we draw our Gantt chart. Now I show you how to find the waiting time. Okay, if you notice here, let's take the waiting time. Here, no arrival time for each process. Here we have amount of work for each one. Waiting time. We start with P1, process 1. How many period of P1? We got 1, 2, and 3. So there are 3 periods of process 1. So we count the start time. In the beginning, we start from 0 plus the start time of the second period. This is our second period. The start time of second period, 24, minus the waiting time. We wait because P2 has interrupt P1. So P1, process 1, was waiting from 5 units. So 24 minus 5 plus, we go into the third period, start time of the third period, 37. Also at 29, P2 interrupt P1. So the P1 was waiting from 29. So 37 minus 29, and we get the total. This will be the waiting time of process 1. For P2, we have only, we have 2 interval, 2 periods of process 2. This one and this the second. So we take the first start time, 5, then the second start time minus finish time of the first period. 29 minus 10, the total will be 24. For process 3, we have only one period, so we take only the start time, and so on. And everyone know how to find the average of total waiting time. The total finish time, just we take the finish time of each process. P1 finish at 39, P2 finish at 32, P3 finish at 14, P4 finish at 37, and P5 finish at 24. So this example for without arrival time. Okay, without arrival time. Let's take the second example with arrival time. So this will be with arrival time. There is a specific mechanism to find or to draw the Gantt chart using or with arrival time. Okay, so this is on the question here. The given quantum is 3 units. The quantum is 3 units. We have also 5 processes. Each process with burst time or execution time and arrival time. So as usual, we start from 0. Okay. In this case, for arrival time, the best way to solve this issue, we need to use the Riddique table. Riddique table. Okay, Riddique table. What is the Riddique table? In this table, we can write down all the processes or tasks which ready to enter the memory. I repeat, Riddique table. We write down all the processes or tasks which ready to enter the memory. We need this table to avoid any confusion. Okay, so as I mentioned before, since we have arrival time, we take a look which first process arrived. In this table, the first process arrived P1 at 0. Okay, P1 arrived there. So since P1 arrived there, we will execute P1. So in this case, from 0, which process ready to enter the memory? We got only one process, which is P1. Ready to enter the memory. So, since it's ready to enter the memory, we write this process in our Riddique table. So, the Riddique table will help us to manage the sequences, which process we need to execute first. So, P1 equals the burst time, 5. Okay, and that's all. So far, we have only one process ready to enter the memory. From 0, 0. So we will execute P1 from 0 until, who can tell me, from 0 until, we can execute from 0 until
3.
Until 3, yes, based on the given quantum. So we execute from 0 until 3. Okay, please remind my steps. The first step, we execute the current process. The second step, we reach to new unit. Yeah, we reach from 0 to 3. we reach to new unit. Since we reach to new unit, we need to check, is there any new processes ready to enter the memory? We take a look, this is in the given table here. P2 arrived at 1. P3 arrived at 3. So we are here. This is in the Gantt chart, we reach to 3 units. So we are here. Means we got also two new processes ready to enter the memory, which is P2 and P3. So we find new ready process, okay? We direct write down the new processes in our ready queue table, following the given sequence. So P2 first, because arrive first, P2 equal the burst time, 3. P3 equal the burst time, 6. Okay, I repeat the steps. In the beginning, we execute the current process, which is P1, because first arrived. After we reach to a new unit, we check how many new processes ready to enter the memory. We got 2 processes, P2 and P3. Okay, we write down this new processes. After we write down the new processes, we check the remainder of the current process, because the total here 5 units. We execute only 3 units. So is there any reminder? Yes, there have 2 unit reminder. We write down the remainder of the current process. 5 minus 3 equal 2. Okay, I repeat, there's 4 steps. The first one, we execute the current process. After we execute the current process, we check, we arrive at 3 units. Since we are here at 3 units, we check how many new processes ready to enter the memory. We got 2 processes. We write down the new processes. After we write down the new processes, we check the remainder of the current process and we write it. That's all. Okay. So then we execute the next. We execute this one, P1. Then we execute the next, which is P2. P2 execute only 3 units placed in the quantum until 6. Okay. So what is the step now? After we execute the current process, what's the step now? We check on the table. We reach till 6 units. So is there new processes at 6? Yes, we got also 2 new processes, P4 and P5. Then we got down, write down the new processes in our ready queue table. P4 equal the burst time 1 and P5 equal the burst time 4. After we write down the new processes, we check the current process, which is P2. P2. Is there any reminder of P2? The total is 3. We execute 3, so no reminder. P2 has terminated its task. That's all. And if you notice here, we already write down all the given process in the table: P1, P2, P3, P4, and P5. So no need anymore to check the given table in the question. We just execute what we have in the ready queue table. So just follow the sequence. Next, P3, only 3 units until 9. Press R, we write down the remainder equal 3. Then P1, only 2 units, 9 to 11. P1 also has terminated this task. Next, P4, only 1 unit until 12. P4 also has terminated its task. P5, 3 units until 15. There is a reminder, will be 1 only left, 1 unit left. After that, P3, till 3 units till 18. There is no reminder, and last P5 only 1 unit until 19. So this will be our Gantt chart for the given question. Let's take a look in our slide. Okay, this will be our Gantt chart. How to find the waiting time? In this case, okay, we have arrival time. Same the previous calculation. We count each start time. Okay, there's two options. There's two ways for the waiting time to job start. We count the start time here for P1 have 1 period and second period 2 period. Okay, start time of the first period minus arrival time. Okay, 0. This is the start time of the first period. The arrival time of process 1, 0. So 0 minus 0 plus the second start time of the second period. Okay, this is the second period. The start time will be 9. Okay, 9 minus waiting time. We wait from 3. So 9 minus 3, we got 6. And same thing for P2. P2, we have only one period. Okay. So just start time minus arrival time. 3 minus arrival time 1. We got the waiting time till job start. Okay. So the formula here, waiting time till job start is the start time minus arrival time. But if we go too many start time, we follow this way. Take a look to P3. P3, we got how many period of P3? 1 and 2. So we take the first start time 6 minus arrival time 3. 6 minus 3 plus the second period, start time of the second period 15. Okay, minus we wait from 9, the finish time from the first period. 15 minus 9, and we get waiting time till job start for process 3, and so on. The waiting time till job is done, it's too simple. We just, the formula here, waiting time till job is done, the formula, the finish time of the process, which is P1. Where's the finish time? Not 3. The finish time will be 11 here. Here we finish time of P1. The waiting time till job is done, okay, minus arrival time 0 will be equal 11. For process 2, finish time of process 2 at 6 minus arrival time 1. 6 minus 1 equal 5. Okay, P3, finish time of P3, we finish at 18. So 18 minus arrival time 3 will be equal 15. Okay, P4, finish time at 12. 12 minus arrival time 5 equals 7. And the last P5, the finish time at 19 minus arrival time 6 equal 13. Okay, this is the difference between with arrival time and without arrival time. Any questions?
No, sir.
So, Vadim, what do you think? Have any question from your student to our students? I cannot hear you. Vadim, I cannot hear you.
Oh, sorry. Can you hear me, Jamil?
Yeah, I can hear you.
Yeah. Dear participants from Ukraine, you are welcome now to communicate to our colleagues from Malaysia, and you're welcome to ask the questions each other, please. Don't be shy. Or vice versa.
I'm
Please?
sorry, can you hear me?
Yeah?
I didn't quite understand what does it mean, burst time. It's a time when CPU is working or what?
Okay, and student, what's the most time?
Yeah, burst time.
What's the most time?
I can.
My student,
What?
I can add burst time is execution time, but the idea is that the students from Malaysia and Ukraine communicate to each other. So please don't be shy and ask the questions to each other.
yeah.
Oh, to each other. I thought I have to ask the question to our lecturer.
I will answer you. This burst time is execution time of process.
Okay.
Yeah, this is amount of work. We can say capacity, we can say execution time, the given execution time for each process. The total execution time. Then we have quantum. Based on the quantum, we can execute each period. Why not, student? Why not participate? Don't be shy, please. Any other questions?
Please participate. Unique possibility to build the bridge.
Yeah, we need you to communicate between each other. So please don't be shy.
Please, any questions concerning the topic of the lecture?
Any questions?
Am I right? I explain what I understood, and you will correct me if I'm not understand something correctly. Okay.
Okay.
So we have arrival time. It's a time when the signal is arrived. Yeah.
When
Okay.
the process, All right, yeah.
It's a process. We have on the picture P1, P2, P3. Under the P1, P2, P3, we have numbers 0, 3, 6. It's a quantum time. Quantum time is a time it's a period, as I understood it. Yes, it's a period.
Again, please, again. The process 1 and 2 and 3, then?
Uh, the quantum time, as I understood, we have the numbers 0. Oh, scroll to the
This one.
Okay.
This one.
This one, yeah.
Okay.
We have the picture P1, P2, P3, etc. Yeah. Under the pictures, there is a numbers 0, 3, 6, 9, 11. This is the time we are summarize our quantum time. As we discussed it
No.
before, it
This
was
is
3.
arrival time. There is no relationship between arrival time and quantum. This is the arrival time. Means process 1 ready to execute at 0 unit. T2 ready to execute or enter the memory at 1 unit, and so on. Okay. The quantum is related to amount of work. The quantum is related not to arrival time, to amount of work. So amount of work, this is the total of work. We should to execute 5 units for process 1. But the given quantum is 3. Means each period, okay, we can execute maximum 3 units. Then we go to next 3 units. Then we go to next 3 units. Based on the quantum, as I said about the quantum, it's the time or period of time for which a process is allowed to run uninterrupted in a preemptive multitasking operating system in one go. So the quantum is related to the amount of work, not arrival time. Okay?
Oh, okay, understood. I understood. Yeah. Firstly, we do first three points of work. Then we go to the second P, the third P, and again we return to the first P to do
No.
the last
We
P.
should. Okay, look. Here, that's what I mentioned. You need to follow the Ridicule table. Ridicule table. Okay. You need to follow the Ridicule table. The mechanism here. Okay, I have an idea. Let's draw it together with you. Okay.
Okay.
We take a new example. Do you want same example or a new example? And we draw it together with you. What do you
Okay.
like? What do you like? Same example or new example?
A new example.
New example. Okay. Let's take this example. Okay.
Yeah.
My students, anyone want to participate and explain the second example?
I didn't quote. Repeat, please.
Huh?
I didn't understood you. Repeat me,
No,
please.
I'm asking my students. Anyone from my students, would you like to participate? No one. Okay. So here, the given quantum is 2. Okay? The given quantum is 2. We start from 0. Okay. So what do you think? Sorry, what's your name? Max.
Max.
Max. Okay, Max. What do you think here? The first step, we take a look. Which process arrived first, correct?
The first process is P1. Yeah.
Exactly, P1.
We,
So since P1, sorry?
we have a burst time 6. It's at what does it mean?
What's that? Amount to 4, or execution time. So, okay, here the first arrived, which is process 1, yeah?
Yeah.
We write down in our ready queue. In this case, as I mentioned before, if the example with arrival time, we need to use the ready queue table. Okay? Not as you mentioned just now, we execute P1, then we execute P2, then we execute P3, then we go back to P1. No, wrong. You cannot say that. It's based on the ready queue table. If without arrival time, there's no arrival time. So in this case, yeah, we execute P1, then P2, until P5, then we go back to P1. Because here, no arrival time. But if we have arrival time, to avoid any confusion, we need to follow the ready queue table. So how to follow the ready queue table? The first step, I repeat one more time. The first step, we check which process arrived first. P1, yeah? So we write down P1 equal the burst time, yeah, Max?
Yeah.
Okay, what's the next step?
P2 3.
Why? P2 3. Why we should to write P2 3? I explain one more time. What does it mean ready queue table? Ready queue table. This is the table where we write all the processes, all the tasks which ready to enter the memory. Is P2 ready to enter the memory? We are at 0 unit. Is the P2 ready to enter the memory?
The process 2 is will be processing after the P1, and when the quantum will be
Look, here we are at 0 unit. Is
okay.
P2 ready to enter the memory? We are at 0.
We are at 0. At
Yeah.
0, the process 1 becomes to be done. Yeah, and
Not to be done, no. At 0 unit, only one process ready to enter the memory. Only one process we can execute, which is P1. Only one process. So no any more process. So we write down in the ready queue table only the ready process, which is ready to enter the memory. So we got only one process, P1. Another process ready to enter.
no.
Another process.
At the time that
ready to. Huh?
when we execute the P1, then
Max, before we execute the next, just follow step by step to understand this mechanism. You need to follow step by step. First step, we are at 0 unit. Okay?
okay.
Which process ready to enter the memory at 0 unit?
First process.
Exactly, only P1. So we write down in the ready queue table P1 equals the post time. That's all. After we write down in the ready queue table, we will execute what we have in ready queue table. What we have now in ready queue table, only process 1. So we execute process 1. Based on the given quantum. Even the post time is 6, but it allows us only to execute 2 units. So the first step, you understand the first step. We check the current unit. We have only one ready process. The second step, we execute the current process. Okay, Max?
Okay.
So we execute P1. This is the second step. We execute P1 from 0
Until 6.
Why?
Or we have to divide it on a part. First P1 2, then another P1 2, and the third one P2.
We need to follow the quantum. We need to follow the quantum. The quantum, the time or the period allows to execute from the total quantum. So we can execute only 2 units.
Yeah, we can execute only 2 units, and
Yeah.
then we have the burst time of the first process 6. So we divide it on 3 parts. Yeah.
Yeah, we can say like that. But follow the way now. So we can execute in the beginning, we can execute only 2 units, yeah?
Yeah.
Okay, so this is the second step. First step, we execute the current process. The second step, we reach to new unit. We reach to new unit, which is 2. Okay, this is the second step. We reach to new unit. The third step, what we should to do now? The third step.
Go to P2 or read again P1 and
We need to check the new processes. We need to check the new processes ready to enter the memory. Okay. Sorry.
Okay, we check. The next step is to check another process. The next process is P2.
P2
and what if P3, P4, P5, or what?
No, look, we arrive at 2 units. We arrive at 2 units.
So we write P2 equal to 3 in the table. Then
before that, we arrive at 2 units. Yeah.
Yeah.
Okay, where is the arrival time 2 here?
The arrival time for second process, or what?
Where's the 2 here? Where's the 2 based on arrival time?
Arrival. We are checking arrival time for the P3.
Not for the P3. Look, arrival time at 0. Arrival time at 1, 2, 4, 12. So since we arrive at 2, so we are here. Means we are here. We arrive until here. means we have two new processes ready to enter the memory, P2 and P3.
Oh, okay, that's clear.
Understand? At two unit, we got two new process ready to enter the memory, which is P2 and P3. So we should to write in the ready queue table P2 equal force time 3 equal force time 3 and P3 equal force time 3. After we write down the new processes, okay, we check the current process. Is there any reminder? Yes, we have reminder, which is P1 equal what, man?
P1.
4. Yes, equal 4. Okay,
Yeah.
this is the first important step. The first one, we execute the current process, and the second, we check the new unit. We arrive to new unit. At 2, we check we are here. Okay, since we are here means we have two processes, P2 and P3. Then we write down, okay, P2 equal 3 the first time, then P3 equal 3 the first time. After the last step, we write down the reminder of the current process. This is all the steps which we should to do. And then we execute what we have in the ready queue table. Okay, there is no any new processor. We execute what we have in this table. We have P2, we execute P2. This is in the quantum, only 2 units.
Only 2 units. So we write
Until
4.
until 4. Okay, so now we reach to new unit, which is 4. How many new process ready to enter the memory at 4?
4 process.
This is done, this is done, this is done. How many new process ready to enter the memory?
Only one, P4.
Only one, exactly, which is
P4.
P4. Excellent. So we write down the new process P4 equal the first time 5. And what the next step, Mark? After we write down the new process in the ready queue table, what the next step?
To check if we have another of this P2.
Another reminder, another process? There's no process. You said only one process. So
P2.
we check.
So we read. So we write down P2 equal to 1, P3 equal to 1, and P1 equal.
No. Wait. You are correct. We write down the reminder of current process. Don't jump to P3. We not execute P3 yet. We are at P2. So we just write down the reminder of the current process, which is P2 equal 1. Don't go to P3. P3 not executed yet. Okay?
Okay.
So then we cross out the P2 equal 3. The reminder would be 1. Okay, the next we execute P3. Okay, so now we execute P3 based on the given sequence in the ready queue table, P3 until
6.
Until 6, exactly. So what the next step? We reach to new unit at 6. What the next step?
There is no one.
We check if have a new process, yeah?
Yeah. But
There
we
is
don't
no new process.
Yeah, we don't
Yeah.
have any new process.
Exactly. The next process will be at 12 only, but we still at 6. So we just write down the reminder of P3. Since no any new process, it would be equal 1. And just follow the given sequence in our ready queue table. So what's the next step after P3?
P1
P1. Until
8.
Yeah, exactly. So next step we check. We reach at 8 units. Is there any new process ready to enter the memory?
No. There is no.
So we just write down the reminder of the current
So
process.
we continue our process. Okay.
Exactly. P1 equal
2.
2.
So
Next,
we are processing P4. P4 until 10.
at 10 units, any new process ready to enter the memory?
There is no one. We continue our process.
Okay. So
Okay. Then we write down P4 equal to 3
Yeah. Then next,
and execute P1 or
execute
P2,
P,
execute P2, execute
P2,
P2
yes. Yes. Until
until 11.
11, exactly. Some students will confuse that 10 to 12 based on the quantum. No, the total here is 1 only, so we can execute only 1. So excellent, we execute only 1, we reach to 11, 11, okay. So is there any new process ready to enter the memory?
No, no.
No, so we cross out, P2 has terminated its task, there is no any reminder, correct?
Okay. So
Okay, next,
then execute in P3
P3 until 12.
until 12.
Is there any process, new process?
There is the last one, P5.
The last one, which is P5. Direct, we write down the new process. P5 equal
P4.
4 start. Excellent. After we write down the new process, what we should to do?
We
We
have to
check the
execute
current.
P3.
Yeah, P3. Is there any reminder from P3?
There is no. There is only one P3.
We execute one. Yeah, there's no reminder. Yeah, no reminder.
Oh,
Nothing left.
we
Nothing
forgot
left.
to cross it. We forgot to cross it. Yeah.
Yeah, we already execute P3, only one unit. So
We are
because
executing
there is no
P1.
any reminder. The reminder you should to write the reminder after you write the new process, not before. Okay.
Yeah.
Step by step. The first you execute the current process, then you check the new unit. Is there a new process? If you have a new process, you write down the new process. After that, you check the reminder, not before. Okay.
Okay.
So what the next?
The next is P1.
P1
P1 until 14.
until 14. Here, no need to check anymore. Here, no need to check anymore because all the processes already enter the ready table. So we just cross out if there is any reminder. There is no reminder. So P1 has terminated its task. Okay.
P4
Then P4
until 16.
until 16.
And write down into the table P4 equal 1.
Excellent. Then
P5 until 18.
18.
And write down P5 equal to 2.
Okay. Next.
P4 until 19.
19.
Cross it, and P5 until 21.
Excellent, Max. So you understand now, yeah?
Yeah, I understand it quite well.
Okay. Thank you for your participation. I think this is your best student, Vadim, yeah?
What?
I think this is your best student, Dr. Vadim.
I think so, Jamil. Thank you a lot.
Thank you, Max. Thank you.
Thank you too.
Yeah, any more questions to students? Yeah.
If there are no questions, I think we don't have no more right to waste your time, Dr. Jamil. Thank you a lot for your interesting lecture, and maybe you want to ask your students to participate somehow or not. Thank you.
Can I have the presentation somehow?
Can you have presentation?
I want to have the presentation you just
You mean the video that it's on?
I want you to send me this presentation. Or how can I get it?
Yeah, sure. I will send it to Dr. Vadim, and you can get it from Dr. Vadim.
Okay, Dr. Vadim.
Okay, I'll try to give it to you.
So, no any more questions? Thank you, everyone. Thank you to join my lecture. So I would like to thank my friend Dr. Vadim Tarupira from National University of Life and Environmental Sciences of Ukraine. Thank you, everyone. Have a nice day. Bye-bye.
You too.
Thank you a lot, Dr. Vadim. Thank you a lot.
Thank you,
You are
sir.
welcome.
Thank you for your time.
Thank you.
Thank you, Jenny.
Thank you, sir.
Welcome.
Thank you.
Thank you, sir.
Thank you, sir.
Welcome to Malaysia, sir.
Thank you, sir.